So as Fiona said, yes, I'm Mike Isbitski, technical evangelist with Salt Security. I'm going to go through these slides pretty quick because I want to save time for questions and answers. We're going to cover quite a few things about how attackers actually abuse applications and APIs, because it's a really common question we get. API security is very challenging to do effectively. We've seen many failures, and even the most mature companies do struggle with it. So there's often the question, why bother, right? Aren't APIs hard to get at and attack? And actually the answer is no, they're actually very easy to find and then abuse. So we're going to talk a little bit about that today. I don't know if anybody remembers this kind of event. It was interesting, but these obelisks were kind of appearing throughout the United States, and actually it might have been worldwide. You might say it's a monolith, which maybe that's a little bit of an API joke. Maybe it's a microservice, right? Not really important, right? But it was these obelisks, right? Like, what is this thing? How did it get here? It's kind of what I was saying, right? How a lot of practitioners view APIs, particularly from the outside in, if they don't know how these things are architected. That's might be how they view an API, right? It's a little bit of security through obscurity. APIs are increasingly the main target for attackers. There's many stats around this. Salt has actually run quite a few surveys. We generate stats from our platform. This really shouldn't be a surprise, right? Many organizations are getting targeted through their APIs or breached, right? Or leaking data, right? There's a lot of kind of outcomes that can come from that. But kind of to the point of today's talk is, well, how do they find them, decipher them, and then abuse them, right? That's really the important parts of this. The agenda for today, it's kind of split into three areas. The first is going to be kind of that discovery or reconnaissance. The second is going to be some common reverse engineering techniques. And then the last is like, how do they pivot once they've kind of discovered that information and automate their attacks, such as to scrape data in large volumes. All right, with that being said, how do they discover APIs? If you are a security practitioner, and I imagine many of you are here at an OWASP conference, you've likely seen many of these passive reconnaissance techniques. Depending on how long you've been at this, maybe that's things like Google dorking, just searching internet search databases, really, right, of everything that's been kind of gathered about companies. It's a really rich source of information, right? Because we're humans, and we kind of we actually expose a lot of data inadvertently, but we also fall into patterns, right? So maybe we start to name servers or endpoints consistently to support that business or functionality. So you can actually start to use this information as an attacker. Some of the less known things are kind of public filings. When you start talking about Securities and Exchange Commissions for public companies, or if a company has patent filings, it can be a really rich source of information about technology, right, and how that company does business. DNS as well, port scanning with Nmap, really nothing new, right? It's traditional, it still works, right, but it is traditional. These have been around for quite a while. Modern techniques, there's many. There's more kind of newer sources of information, such as Crunchbase, where you might start to harvest information about a target. There's a lot of data that's already been gathered, right? You don't have to scan a target. That's kind of what Project Sonar and Shodan have, right? They're actively scanning every server and endpoint that's exposed on the internet. So you can actually just kind of query that and save yourself the effort of having to scan, right, and that time. Social media, really rich source of information as well, right? We end up sharing kind of information inadvertently. Git repos and Git hunting. This is actually a really significant problem, right? Kind of secrets exposure or leaking intellectual property. Really common though, right? We stash code and infrastructure as code in Git repositories. Tells you quite a bit about how the company might be organizing its systems and APIs. S3 buckets, cloud metadata, right? There's no shortage. If anything, you have to kind of shut this down at some point, right? You could spend months kind of gathering information about a target, and in some cases, attackers do, right? Particularly if it's nation state sponsored. The other that we're actually going to talk about a little later is inspecting mobile apps and picking them apart, all right? Because the reality is, anything you want a consumer or customer to use, typically you're going to publish those things to public app stores. that's freely available, right? You can take those binaries and start picking them apart. Very briefly about methodologies. Security practitioners sometimes get hung up on these. It's important to remember that they're useful for kind of organizing your thoughts about how somebody might attack something and then how you might defend against it. The reality, though, is that it's much more continuous, right? It's not this sequential process, and depending on what the end goal is, or the attack vector or resource that they're targeting, things like persistence may not even matter, right? You want reproducibility, certainly, if you find a bug, but you don't really want to plant some firmware or malware that's going to allow you to kind of create a backdoor, right? Once you've found a vulnerable or a flawed API, you're going to continue to target that thing. You don't want to have persistence, because now you're leaving tracks, right? And then you get into this methodology of having to cover up your tracks. So many app attacks don't actually kind of follow this methodology. They'll bounce around, right? Scan. As you find something that looks kind of suspicious, you might start attacking that thing stealthily, right? Kind of evade detections. So methodologies, look at them, but don't waste a ton of time on them. Reverse engineering techniques. So this is where it starts to get a little interesting. There's actually some OWASP tools on this front, particularly OWASP Z attack proxy. Another one very common in industry is Burp Suite, from Portswigger. There's quite a few flavors of that. There's a free open source version, so you can start tinkering. But there's also free kind of or alternative debugging focused intercepting proxies that are very common, like Fiddler. Typically you'd find a developer might be using something like Fiddler because it's more kind of focused on app performance, right? And APIs and pages, like how are things loading? What's the response time? And then Charles Proxy kind of becomes common on Mac OS. Developer tooling. It can actually be used certainly by security practitioners, but also by attackers. So things like Postman can actually be used maliciously, right? Because it allows you to kind of exercise an API programmatically, kind of see how it responds, and then you start adjusting things. Developer IDEs, certainly in scope, right? If you have code or you have decompiled or disassembled code, these things also become incredibly useful. So Visual Studio and Eclipse can become an attacker tool. Debuggers, decompilers, and disassemblers, there's a lot. I would say usually the journey is attackers will start with something like Android or picking apart Java apps because it's a little bit easier to grok and learn the concepts, and then they might start moving to lower level languages or machine languages, and that starts to become common on Apple operating systems like iOS on mobile devices. But there's no shortage of debuggers, decompilers, and disassemblers. So how does an attacker kind of figure out how the API works? I mean, this is kind of the flow, right? Whether it's Burp Suite or OWASP Zap or Charles Proxy, you name it. This is typically how somebody would do some of that reconnaissance to understand, well, how do the APIs get hit in a certain sequence? In this case, I'm actually just proxying my Google login. I wasn't, it was really just for the purpose of generating the slides. But I want to see, well.
Sorry, Michael, I just want to let you know that you're not actually sharing your slides.
Oh.
So we can just see your video. So
right.
I don't know, maybe you had it on the wrong screen.
Yeah, let me, yikes. All right, let me backtrack a few slides then.
Yeah, it was just, when you referenced something that you were clearly sharing there. Right?
Yeah.
A good time to pop in.
Okay. Yeah, so these are in the slides. I apologize for that. Hopefully they're visible now. Is it, Fiona?
Perfect. Yeah, we can see that.
All right. So sorry about that, everybody. It's Friday. Hopefully everybody's ready for the weekend. So yeah, here's the list of the tools. You'll have the slides. But yeah, the thing that I think is of most interest, I'm glad Fiona chimed in, is that this behavior of how an attacker would try to understand how are the APIs hit in a certain sequence. I'll start to proxy my user session, right? In this case, I was just hitting a Google web app. I want to see what the authentication and authorization flow likes. So I submit my password. That's not my password. I mean, feel free to try. You're probably going to lock out my account. and then I'm going to observe, what does that look like, right? And these are the things that those intercepting proxies expose to anybody, right? Whether it's a user, developer, security tester, or an attacker, you get the same information, right? Because I'm actually observing what's being sent to my client machine or mobile app, and these can be encrypted communications. I mean, in this case, it's clearly HTTPS, and it's Google, so they're using the latest version of TLS. But you can see exactly how that API endpoint responds to queries, and then the data it's returning. Right, you can see my password is submitting there in the message body. And then what does the response look like? Right, it's a post payload here, and then I'd start to pick apart, like, well, how are they handling their authorization flows? And if it looks suspicious, then I'm going to start to pivot and manipulate parameters to kind of attack things. So very common, right? This is kind of how most attackers approach figuring out how APIs work and then reverse engineering them. I talked a little bit about intercepting that encrypted communications. This is a big one. I ran into this often as a practitioner when I was doing the testing. App teams often didn't understand because they were told, if you're doing TLS and you're behind SSO, or you're using the trusted identity and access management systems, your app's protected. It's very misleading, right? Because you're talking about an authentication and authorization mechanism for one, and the other is transport protection, right? Or encrypted traffic. There's still a lot that can go wrong, right? And those are very easy to overcome as an attacker. So, in this case, I was just intercepting my own mobile application traffic, but this process is very similar, right? Generate the trusted root certificate authority, implicitly trust that on the device, or explicitly trust it. And then you can start to decrypt communications. And you might say, well, I don't own the device. How am I going to push a certificate that I can intercept communications? There's many techniques. Typically it was referred to as man in the middle. These days it's really person in the middle, right? It's not gender. But there's many techniques to compromise that encrypted channel, right? So TLS, yes, you should do it, but it's not going to buy you much other than hopefully that communication is protected in transit, but that's not even a given, right? And these are kind of where zero trust concepts might come in, right? Always presume the device or environment is compromised, and you need to be kind of doing better at security. So I won't run through all the potential attacks, how you might intercept traffic. There's quite a few. Mobile hotspots, targeting them at like a Starbucks. Maybe TLS isn't configured properly, or somebody's using an old version of SSL. They have known exploits. So there's many ways that you can kind of decrypt these communications as an attacker. But that's not it, really, right? Like, that would be if I wanted to target a user and an app on a specific device. In this case, I just want to know what the API is, and then I'm going to target that directly. And this one's really important because it's actually based on some research that our Salt Labs division produced, and the report's linked at the end. But many organizations rely on API gateways and web app firewalls to protect their applications and APIs. The problem is most modern API attacks don't follow well-defined patterns, right? We had a little bit of that in the last session. There was some discussion about security testing tools and WAFs, how they're kind of more traditional. Really, they're signature-based, right? So they're looking for kind of known malicious character sets or patterns. Your APIs that you're building or consuming, like in the case of an integrated supply chain, that's going to look drastically different from one organization to the next, right? And this specific case here, this is actually an example of a broken object level authorization flaw and attack. But for one, the attacker will first get the authenticated session. So your authentication and authorization has already kind of been defeated in a sense, right? I can get an authenticated session from either hijacking that communication or intercepting, putting something malicious on the device, you name it. There's many, even phishing, right? So we have an authenticated session. And then we're going to manipulate the parameters, right? I was talking about that with the intercepting proxies. So adjust file parameters or ID parameters or object identifiers, really, right? And it could just as well have been something in a post payload In this case, it was GET requests, so you're just manipulating things in the URL directly. And then the server responds with the data, right? Because it's not checking, are you actually authorized to access this piece of data? And in this case, that piece of data was actually an image of check, personal bank check. Major problem, right? That's kind of nightmare scenario for a bank. So you could access data that you weren't authorized for. And this works often, right? This is why BOLA is #1 on the OWASP API security top 10, because it's really hard to get authorization right? You have to be continuously verifying authorization throughout a session. It can't just be on initial login. What happens if somebody compromises the session, gets a hold of an authenticated session cookie or OAuth token, right? There's many different attacks that target the authenticated state. But yeah, many attacks actually occur in authenticated sessions and in encrypted channels. All right, so how do attackers automate their API attacks? We kind of ran through the basics, right? How do they intercept the traffic? Or how do they find the APIs, and then how do they intercept where they can start to manipulate API calls? So, presumably, many attackers are going to start to pivot now, right? If I know that this API exposes some data, may want to scrape or, enumerate through the entire user database or check image store, right, to extract everything, right? Because now I could have a giant treasure trove of information. Maybe I want to resell that. Maybe I'm going to demand ransom from the target, right? There's many scenarios. One of the most common, though, that we see across verticals is really credential stuffing. And this often gets conflated with account takeover. Really, the attack pattern is credential stuffing that leads to account takeover. That's kind of the end goal. But the first step, it's what we've been talking about. Perform that reconnaissance of a given target, discover its APIs. That's what I'm going to kind of zone in on. In the case of credential stuffing, I'm actually going to be working from a data set of known working credentials at one point or pilfered credentials. It could be from that target. It might actually be from anybody, right? There's many repositories of stolen or leaked credentials now that attackers can use and then use in their tools to automate attacks. And that's kind of the next step, right? Even to something like Burp Suite or OWASP Zap, you can actually feed those user credentials into the tool and now target an API endpoint, run through all the credentials and do it with throttling, right? And that's really important because, like I was mentioning with API gateways, another kind of often used mechanism is rate limiting, right? If I'm seeing more than, 10 requests in a minute, I want to start blocking that connection, maybe terminate the authenticated state, redirect to some authentication page, you name it. But as an attacker, you can kind of probe for those things, right? And then adjust your request rate down to evade that. And that's what attackers do. And then launch the attack, right? In this case, it's against the login API because I'm attempting to take over a customer account or employee account. And then I have to track as an attacker, did the login work? Because typically I'm doing this against thousands of users and potentially a much larger database of originating credentials. Taking this to the next level, I mean, typically when attackers do attempt credential stuffing, they distribute their attacks and geographically, right? And it doesn't mean that I need to be in those locations. I just need to deploy my scripts or tooling on machines in other locations, which is really convenient, right? When you think about cloud service providers, as an attacker, you can actually leverage AWS to attack other targets, and that does happen, right? And that's often a trusted IP address space too. So really tricky. We see this very commonly when it comes to credential stuffing, where it's distributed and throttled. And attackers, I've kind of been alluding to this throughout, but it's always throttled, right? Distributed to kind of evade detections and kind of trick, security process or SecOps, whoever's monitoring for this, likely not going to see it because it could look like any other authentication failure. Or low and slow, right? That's another kind of term that's often thrown around. Wrapping up some of what we've been talking about, API attacks are really common. I mentioned the OWASP API Security Top 10. It's new, right? It's 2019. Most practitioners are more familiar with the Application Security Top 10, maybe mobile, but maybe even less API Security Top 10. And there's uniqueness across all of them, right? So it's not universally known. I talked about that credential stuffing, how it's often mixed up with account takeover. That is very common, but so is where it gets mixed up with brute forcing or application level denial of service or distributed denial of service, right? There's a lot of kind of confusion on what an attack is, and your response or mitigation actually needs to be much different depending on what the attacker is attempting. Now, what does it mean if an API is leaky, right? Well, typically it's exposing too much data, or it might have weaker authentication and authorization that kind of leads to the ability to enumerate and scrape data. Attackers are learning faster than security practitioners, unfortunately, right? They know this kind of reality of cloud computing. Traditional security controls are often built against or built to use rate limits and IP address blocks or allow deny lists. So just spin up some compute, launch an attack, move to a next resource. Very common for even a semi-advanced attacker. And those traditional approaches, I've kind of been talking about this, right? They're just not architected for this world, right? WAFs and gateways. We talked about rate limiting, but threat protection filters, those things that rely on rules and signatures, are often not well maintained, or it's very hard to tune them effectively for all your APIs at scale. It's just where most organizations fall down. How we approach it at Salt. I'm going to run through this quick because I want to make sure we have some time for questions. But really, it's, when you think about your enterprise architecture, you likely have a lot of network elements, different things serving APIs. You really need to gather all that data, right? Because that's going to provide your API telemetry that you can now to hopefully start to pick out these signals, right? Indicators of compromise, or in this case, API abuses. There's an AI powered engine, or ML, that analyzes all of this traffic for patterns, and it's unique to your environment, right? Because I mentioned how APIs are often coded with unique business logic, so they're going to look very different from one organization to the next. Collectively, that's the context-based API analysis architecture, or C3A. And all of that data feeds the protection platform itself. The primary use cases that we often see, it's discovery, right? We talked about how attackers discover APIs, but actually a lot of organizations have trouble discovering all their APIs as well, because there are a lot of systems and applications that you're procuring, integrating, building. It's a lot to kind of keep track of. And then how do you know if you're actually under attack, right? That's often a tough question to answer, right? And which style of attack, right? Your SOC might only be looking for ransomware, and they're not actually versed in applications. And then improve posture over time. This actually kind of feeds more into DevOps or like feedback loops. But as you find issues in your APIs, you want to be fixing those things. And it could be a code level fix, but it might also be infrastructure, right? Maybe a rate limit is appropriate. Maybe you should be challenging for authentication and authorization, so you need to do a handoff to access management. Just some other kind of characteristics of the platform. Yes, it does address the OWASP API Security Top 10. That's not easy to do, right? There are quite a few items in there that basically throw out all the traditional mechanisms, right? They just don't work. At best, they can handle some of the injection flaws, but not all of them. And that's only one of the top 10. And we need to integrate with your existing proxies, right? Proxies become a problem when you start talking about API performance. You don't want to be introducing additional proxies. There's a lot of resources here. This is kind of my entire focus at Salt Security, is to generate content for practitioners and kind of raise awareness about the problems of API security. How can you improve things? How are attackers working? I mentioned the threat research reports from our Salt Labs division. Take a look at them, right? Because it describes how attackers go about finding the APIs and then exploiting and abusing them. My contact info is there as well. So with that, I will say thank you, and hopefully we have some questions.